President of the United States, the Honorable Al Gore.
Thank you. Thank you very much. So excited to make this presentation on Climate Trace this morning, and I want to ask my colleague and partner in the Climate Trace Coalition, Gavin McCormick, to come out and join me here. He's going to take a seat on the dais here, and we're going to go back and forth in presenting some images, and we're going to present a lot of data for you that is meant to assist anyone who is trying to find out the specific location of the greenhouse gas emission sources all around the Earth. I want to start with some images that some of you are probably familiar with. The overview effect that we've all experienced in looking at the image of Earth from space still has an emotional impact on me. And of course, the basic problem that's causing the climate crisis is that we are putting 162 million tons of man-made global warming pollution into the sky every single day. And we're treating the sky as if it is an open sewer. And this blue line that shows the troposphere, you already know why it's blue. That's largely the oxygen that refracts the blue light of the spectrum. But what's so striking about this thin blue shell that surrounds our planet is that it's so thin. If you could drive a car straight up in the air from the ground at highway speeds, you would get to the top of that blue line in about 5 to 7 minutes. You could walk it in an hour if you walked fast. And that's what we're using as an open sewer for all of the pollution that we're putting into it. And it lingers there. On average, each molecule stays about 100 years. And this is a new updated figure. The accumulated amount now traps as much extra heat in the Earth's system every single day that would be equivalent to the heat released by 750,000 Hiroshima-class atomic bombs exploding every day on the Earth. Hard to comprehend that much heat, but that's what we're doing, and that is the problem. That's what's causing the climate crisis. That's what's driving temperatures up year by year. And you know, there are still, 28 days left in the 12th month of this year, but already the scientists are saying it's certain that this year will be the hottest year ever measured with instruments. Not only the hottest, but the hottest by a record-breaking margin. And these kinds of measurements are startling scientists this year particularly all around the world. The 10 hottest years ever measured with instruments have been the last 10 years, if you count this one as the hottest of all. And overnight, we got the new figures for the month of November globally. These are all the Novembers going back to 1955. And you can see that this November, just completed, is not only the hottest November in all of history, but again, the hottest by a record-breaking margin. And again, the scientists are saying, we're seeing something new. This climate crisis has been moving to a new level of seriousness, and we have to develop a new strength of resolve in fighting for solutions to this climate crisis. And the Secretary General said it as well as anyone possibly could 2 days ago in the opening ceremony here at COP28, and he said, we can solve this, but only if we stop burning all fossil fuels. Not reduce them, not abate them, phase out fossil fuels. That is the solution to the climate crisis with a clear time frame. And you know, as with some of you, I've gone to these COPs for quite a while, and it's very common for people to ask a question. Do you think this is going to be a success, or could it be a failure? Well, what do you think is going to happen? Well, there's a clear test. If we develop a commitment globally to phase out fossil fuels, this will be a historic success. If we do not, it will not be a success. It's very clear. Don't be distracted by any bright, shiny object that's held up to distract attention from the main job. The climate crisis is mainly a fossil fuel crisis. So the reason why people around the world are hoping that it will be a success is what's been happening. Look, in China last July, 52.2 degrees, 126 Fahrenheit, the hottest temperature ever recorded with instruments in China. In Argentina, in the middle of their winter, 38 degrees Celsius, 101 in the middle of winter. In Brazil, just 3 weeks ago, 44.8 degrees in November. Here in Dubai, this is a particular concern for this region because during the summer of this year, the feels-like temperature, of course, as you know, the combination of heat and humidity, has ranged from 55 to 60 degrees centigrade, 131 to 140 degrees Fahrenheit in some areas. And what that means is that this region is in danger of developing such high temperatures and humidity that it will become, in some parts, physiologically unlivable. And scientists have been warning about this for a while. There are uninhabitable areas now, but they're relatively small. But the projections are that the climate crisis is going to be enlarging them. I'm going to go back on that slide so you see the expansion here. Yeah, that's it. Okay. Most of the heat is going into the ocean, down 2,000 meters, and half of this astonishing increase has come in the last 20 years. And many of you know what that causes. The ocean-based storms get much stronger. This is the first year in history that Category 5 cyclonic storms have appeared in every tropical ocean basin all over the world. And these storms, there was a story in one of the major newspapers in my country this morning, that these storms, the preponderance of them have been rapidly intensifying, as predicted. Here's an example from just 6 weeks ago, Hurricane Otis. It went from a tropical storm to a Category 5 hurricane in such a short period of time. The people did not have any warning. They didn't have a chance to evacuate, to save their families and their property, and the destruction was devastating. And of course, when the oceans get this hot, the evaporation increases, fills up the atmospheric rivers, and we get these rain bombs. And actually, last week, 1.5 million people, this is still going on today as we meet here, 1.5 million people in East Africa driven from their homes. This was in Hong Kong 2 months ago, the largest rainfall ever measured in Hong Kong. 154 millimeters of rain in 1 hour. And these rain bombs are becoming common all around the world. 500 millimeters of rain in 24 hours. And of course, some of you know the thousands of people that were killed when the rain bomb in Libya caused 2 dams to burst, and the whole city of Derna was utterly destroyed. Many of the bodies were washed out into the ocean and never recovered. And this kind of tragedy is becoming very commonplace. In fact, in the last decade, $2.5 trillion was lost to these extreme climate-related disasters. That's an increase of $1 trillion from the previous decade. And you know, the scientists have been spot on in predicting these consequences, and because of that, we should pay more careful attention to what they're telling us will happen in the future unless we act, unless we phase out fossil fuels and come to a solution for this climate crisis. And the extra heat's causing the droughts, of course. The Amazon River is now at the lowest level it has ever been measured at Manaus, and the Amazon River, the Rio Negro, Rio Salome that come together in Manaus, lowest water levels ever measured there. The Panama Canal is turning ships away because the drought in the region is making the canal inoperable for some ships. The drought in China has been particularly devastating for the last few years, and the fires in Canada, as many of you know, Each of these larger symbols is over 400 hectares of fire. This is really unheard of before this time. But we are also seeing with the climate trace data some diminishing of fires in some regions. And I want to explain to you why the climate trace data is so important. This is a global stock take this year. We're supposed to take stock of what's happened since the Paris Agreement. This climate trace data can, we believe, be very helpful in creating a more accurate and more complete stock take. Why? Why do we need it? Well, for one reason, there are 71 countries that have not submitted any data whatsoever on emissions since the Paris Agreement, the period covered by the stock take. There are more than 100 nations that have not submitted any inventories for the past 5 years, and no nation has submitted an inventory for last year. Climate Trace, we're going to give you all that data in all of those categories for every nation starting this morning. So, the Climate Trace data looks at the Earth as a whole, and you will see each of these spikes, depending on how tall it is, that's the amount of greenhouse gas pollution. And every one of these data sources can be clicked on. You will find the metadata, who owns the site, how much greenhouse gas pollution. We have more than 350 million point source greenhouse gas polluting sites in this database from every country in the world. And this is a color-coded overview of the global total. Who are we? We are 12 organizations, data scientists, climate scientists, and others who work together to break up this problem, and 100 other contributing organizations and individuals that provide data. I want to single out Planet Labs. My friend Will Marshall and his team give more images than any other source. And I want to thank those who help us with resources, and the Patagonia Holdfast Collective, and my friend Yvonne Chenard is one of the new ones. These are all of the contributing organizations. And I want to set up, before I give it to Gavin McCormick, and Gavin, come on out here. I want to tell you a story that illustrates the importance of using data to solve problems. Some of you know the story from the 1850s when there was a big cholera epidemic in London. And it was before they understood microbes, but this doctor famously found a pump. This is a replica of it, because he put dots on the map of all the cholera cases, and then he triangulated and found the source of the spreading disease. We do something very similar with Climate Trace, and I'm going to ask Gavin to take over at this point, and I'll come back.
Thanks, Rich. So how is it possible to measure 350 million different steel plants, factories, airports, forests in a single year? Well, the only answer, of course, is that it takes 100 organizations working together and working with software. The only way you can get this kind of scale this quickly is to use software, in particular artificial intelligence. So the main method that we use, illustrated here, is we have a fleet of over 300 satellites. We don't own these satellites. We source them from governments and corporations around the world that are looking directly at emitting facilities around the world. I'll explain in a moment more why we use that kind of unusual approach. But we look directly at these facilities, and we train artificial intelligence algorithms to know, what does it look like when a facility is polluting? So in these examples, for example, we have been able to detect the steam coming out of a power plant. And using visual imagery, we can train an algorithm at the moment the steam looked like that, how much pollution was coming out of that power plant based on a ground sensor. At the moment it looked like that, how much pollution was that? And if you get many images of this, you can actually get an AI algorithm that gets to be quite accurate at knowing, what does a power plant look like when it's polluting a certain amount? What does it look like when it's polluting a different amount? So we combine all that, and one of the things that's been really interesting, we initially assumed the best way to spot emissions would be to look for emissions, and it works. So for example, this is on the image on the left is from the OCO3 orbiting carbon observatory. It's the most powerful carbon detecting satellite on the planet. It has been now demonstrated that for 12 of the world's largest, most emitting power plants, you can directly estimate their emissions through this technique. However, what surprised us is you can actually do better a different way. So a different technique, here I'm demonstrating the STEAM technique, and I'll talk about more in a moment, is to look with visible light, not looking with spectroscopy to detect CO2 directly, but looking at things that the human eye can pick up, that it turns out you can see them better, and every time that happens, that is very, very correlated with emissions. So to our considerable surprise, the method that seems really obvious, let's look for CO2, it works, but another method works better. So you might think that our next step is we would only use the method on the right. But as a coalition, using AI, we have a different approach. We can use both methods. So what our algorithms do is they combine both methods, and using both types of satellites, we collectively predict what are the emissions of this asset. And once we hit upon this idea of combining methods, what we learned is that you can just sort of keep going. So we now integrate dozens of different techniques. Thermal infrared, just like in the movies. For example, steel plants burn really hot when they are emitting, and that's very well correlated. Co-pollutants. In a lot of countries, we're able to detect pollutants like NOx, which are a really good indicator of GHG emissions, actually. They always happen at the same time because the chemical processes are linked to a physical real-world facility. We use the automated information identification system that ships use to avoid crashing into each other. Why do we use that? Because if you can know where a ship is and how fast it's moving, that actually turns out to be a really good predictor of its emissions if you also know the engine class of that ship. And that's why we look at things like textual analysis of the sale of emitting assets. People will often, when they're selling a power plant or a ship, they'll include the design specs. Great. That's public information. Our algorithms can pick that up as well. We combine that with market data, and essentially the idea is that over 100 organizations sharing in a consistent format dozens of different signals in an automated way can just get better and better and better at cross-validating. How do you know these data are right? And so as a result of this, we've been able to monitor every single sector that we have been able even to find that it exists. Some of these sectors I didn't know were a thing, and we've had to learn about them. But across our many organizations, we have a comprehensive global way of detecting essentially every form of emissions now. And the reason that matters is because at the end of the day, why do we have emissions? Because actual real facilities are causing these things. So we've learned that an algorithm that understands this is a car, this is a steel mill, this is an airplane, this is a rice farm, will do much better than a one-size-fits-all solution or an inventory that isn't thinking about what are the real-world effects really driving climate change. So we put all that together, and we were able to get an inventory, which we're going to show you in a moment, of individual facilities. So for example, this is the world's largest oil field, the Permian Basin in Texas. Anyone could go onto climatetrace.org as of a few minutes ago, and this is now all public free data. You can see our estimate of the emissions, you can see our estimate of what type of facility, even things like the owners. And you can do this for essentially every type of emissions there are. So the world's highest emitting power plant, the world's highest emitting cement plant using a totally different technique. One of the things that we think is really interesting is when you look at the dirtiest facility in the world of each different type, notice they're in a mix of countries. We've got Korea here, we've got the United States, we've got China. We were really surprised to see, even though we're used to talking about a country might be the most emitting sector in the world, individual facilities are really spread out all over the world. For example, this is the airport that most of us probably flew here in today, or this week. It's the world's most emitting airport, probably because it's the largest. We have the highest emitting port in Singapore. And as you see, what this allows us to do is get a specific inventory of who is causing climate change, what exact facilities are doing what, and verify it with real-world visuals to make sure the data are real. Then we start to analyze those data. So one of the results that we found that's actually a very happy result, although global deforestation emissions are still high, they actually declined last year. And so in Indonesia and the Congo Basin and several other countries, actually we saw a drop in forest fire emissions. And that is the type of thing that we can now see at a very precise level. So the other thing this allows us to do is not just in the stocktake, but for others in the climate community, provide the best data that anybody in any of our many, many shared organizations has been able to find. So for example, one of the techniques that climate modelers need to know is where are emissions coming from so that they can train their models. So the WMO does a wonderful job of gathering many, many high quality models, and they'll use information like where are all the landfills in Mexico that allows us to pinpoint what we would expect to be happening with methane. We have been able, using visual detection, to find far, far more landfills than were previously known. We think this allows the possibility that many countries, not just Mexico, they didn't know how many informal landfills are out there. The actual amount of emissions in this case is about twice what was previously believed, and also the physical dispersion of those sites is different, which matters if you're a climate scientist. And so then we also wanted to make it possible for anyone to see the data and to go in and look, how do I know this is true? So in the climate database, you can actually see images of the facilities we're talking about, and we've been able to pinpoint and independently verify, like, yeah, that is in fact a landfill. The AI algorithm isn't hallucinating, it's not telling us something unusual. Humans doing actual spot checking of all these facilities have verified this is all actually happening, and you can check for yourself. One of the things that was really interesting and inspiration to this project was the US EPA database. I think the flight database in the US EPA is one of the best high-quality asset-level public databases out there in the world. Our inspiration for this project, in part, was to make every country able to have something like this. That's why it really surprised me when we actually blew past that database and are now able to detect many, many more facilities. Why is that? Just because so many organizations using so many different techniques have been pooling their data, the sum total is actually quite a few more assets. An example of a type of facility that the United States actually doesn't monitor very well is agricultural feedlots. When you have a factory farm, the US really does not have a good inventory of that, and we've been using machine learning to spot them from space and pinpoint them. So all this data is publicly available, and as a result, we have an emissions inventory that is available free to anyone. It's a complete inventory of every country in the world. Importantly, the data quality is the same for non-Annex 1 countries as for Annex 1 countries. We really wanted to avoid the historic problem of some countries having access to higher quality data and technology than others. So we use the same methods throughout the world, and we make very sure that the system is globally comprehensive. With a satellite, you can do that. It doesn't care about national borders. We have this through 2022, and importantly, our estimates are not derived from self-reported estimates. This matters for a lot. For example, a company that is emitting a lot might not have the right incentives to reveal all of the information about its own emissions. An independent estimate from space doesn't have that risk of bias. We cover all anthropogenic emissions. My understanding is this is everything covered in the Paris Agreement plus international aviation and shipping. But the point is, this is all the human-caused emissions that can be spotted from space are in one database. And it covers the various gases, CO2, methane, NOx, as well as an ability to calculate the CO2 equivalent when you put them all together. So we think this is very useful in the COP context for a global stocktake. However, there are other features, if you go to all this trouble of building a database like this, that we hope might be helpful to others in the environmental community. So another example of features is we go back all the way to 2015. This makes it really useful when you want to compare with different data sets. If matching up, one of the big problems we found is that many different inventories have been done in many different years. Having an estimate of every year makes it more comparable. We also have a detailed breakdown by 53 different sectors and the many, many, many assets worldwide. We've also really endeavored this year to provide metadata. What's our uncertainty? Very helpful for other scientists who want to double check our work and add on it themselves. What is the facility type? How often was that facility turned on? What is its capacity? These are all things that you can cross-verify the data sets in different ways, which are very helpful for validation and accuracy. We've also just worked really hard to make sure this is a database anyone can use. It should feel as easy as using Wikipedia. You can search for all the assets owned by a particular company. You can search for all the polluting facilities in a particular city. You can slice and dice the data in different ways. And it has various convenient data formats. So if you're a software developer, you can use JSON API. If you're a normal person, you can just point and click. And if you're like me, you can use Excel. And so I think the sum total of this has been over 58 billion tons. This is our best guess when you add up every asset in the world of precisely what is the global human-caused total. Note this is slightly higher than other previous estimates because we in fact have found various assets around the world that are emitting that we believe were not in prior inventories, leading to a larger total. And of course, as I was mentioning, this creates a database that gives an ability to add up for any country and any sector. We just wanted to make it possible, again, even some smaller, often ignored nations are on this database. We really, really wanted to have this not have the bias of just a few countries having high quality data, but make it available for the entire world. Great, I'll hand the mic back.
Thank you, Gavin. Great job, pal. Gavin, I'll hand it back to Gavin in a few minutes. And this is a slide some of you are familiar with, and this is the principal source of the climate crisis, the burning of fossil fuels. Look in the upper right-hand corner of that graph. That's the pandemic, that little notch. It went down in the pandemic year and then went right back up. But let's take a closer look at that data. You see the pandemic year, and since the Paris Agreement in 2015, global emissions have increased by 8.6%. There were a lot of pledges, and it was a great meeting, and a lot of good work was done there. But emissions have gone up, and it went up again this past year, another 1.5%. That's the problem. And the increase in global emissions is really concentrated in just 5 countries. Well, there are many countries, but 2/3 of the increase in the global emissions over the last 7 years came from China, India, Russia, Indonesia, and Iran. Other countries, including the United States, certainly contributed. But of that increase, more than half of the increase comes from 5 specific sources. Number one, Chinese electricity and district heating of buildings. Number two, new electricity production in India from fossil fuels. Number three, production and transport of U.S. oil and gas production through pipelines, the so-called gathering lines that bring from the fields to the pipelines, and the trains and ships transporting oil and gas. And then number 5, Chinese coal mining. So these increases, and Chinese steel, number 5, sorry. Coal mining was the 4th one, and Chinese steel is the 5th one. And then there's all the rest with lots and lots of other sources, smaller than the ones that are highlighted here on this graph. China's emissions since 2015 have increased almost 19%. But in this past year, they've gone down. It's too early to tell whether that could possibly be a peak. The growth rate has slowed a little bit in China's economy, but this is potentially a hopeful sign. And in 2021, over 100 countries representing 70% of the global economy met in Glasgow and made a global methane pledge. We had another one yesterday, and we stayed up most of the night gathering data to interpret this pledge yesterday. But I want to recall for you that 2 years ago, there was the global methane pledge to reduce methane emissions by 30% by 2030. Well, what's happened? Well, since that pledge was made, methane emissions have increased almost 2%. So yesterday was a really important agreement when 50 oil and gas companies pledged to work toward near zero methane emissions. And all those who were part of that, including the UAE, I say congratulations. This was a wonderful pledge. But let's take a look at it. The top national methane emissions from oil and gas are listed here, but only 4 of the top 10 were represented in the pledge yesterday. And actually, the companies that have signed the pledge only have significant ownership of 10 of the world's 25 highest methane emitting oil and gas assets. So let's keep this in perspective. And it relies on self-monitoring and self-reporting, but we're going to be measuring whether they comply with this or not. It could be a very meaningful step forward, but a lot more work needs to be done, and quickly. because we have seen pledges in the past and we have seen misbehavior by oil and gas companies in the past when some of them, as many of you know, relied on massive outright fraud in trying to convince publics around the world that there was no climate crisis. And so the same PR firms that worked for the tobacco companies in saying that there was not enough evidence or scientific consensus on secondhand smoke, for example, and they hired actors and dressed them up as doctors to say that smoking cigarettes was fine. The same PR firms have worked for the oil and gas companies saying that the science is not settled there. They've become more sophisticated now, but they're still up to some old tricks. Now, the Abu Dhabi National Oil Company still claims to have no emissions of methane or anything else from the transport of oil and gas. Well, actually they do. We can see them from space. And by the way, the head of NASA, Bill Nelson, my friend, is here in this audience, and I'm appreciative of him being here. But why can we see the leakage from space if there are no leakages? Well, their self-reported emissions, there's been no report since 2014. The closest we have is 2015, and these are the actual emissions, and these are the emissions last year here. So monitoring and not relying on self-reporting is important to make these pledges meaningful, because it's easy to pledge, it's easy to promise, and if there is no monitoring and no enforcement, then the pledges may not last. All of the self-reporting in the world by corporations only adds up to less than 15% of the global emissions. This is from corporations on methane. And there's a big bias because in large regions of the world, it's very uncommon to have any self-reporting. So these are all the major emitting sites, all of the significant emitting sites in the UAE. And you can see the totals, you can see the different sources in the legend. These are almost 1,000 individual sources of greenhouse gas emissions. And we have this for every country, as Gavin pointed out. And you can click on every single one of these sites, all 352 million of them around the world. If you want to focus in on the country where you live, the city where you live, the industry that is important to you, you can find all of this at your fingertips, and it's free and available. Here's some examples of what it looks like here. And up until this past year, emitters in most countries around the world could simply choose not to disclose what their data is, or to hide it by selling their assets to some dark private equity firm or to some other company that didn't report it. There are plenty of examples of this, but with Climate Trace, if you try to do that, we still see it. You can't get rid of it without us finding who you gave it to, who owns it, and who's operating it now. Here are some examples. This is Gavin, wasn't named after Gavin McCormick, but this is the Gavin coal-fired plant in Ohio. American Electric Power, sold it to a private equity firm. They took it off their books, and as far as the public is concerned, those emissions were sharply reduced. They didn't show up anywhere anymore, but they show up in Climate Trace. We still see it. When it was owned by one owner, it may have a different name, but it still is emitting the emissions. We still see it. Here's another example of a high-emitting source that was sold to a new owner that didn't report the emissions. We can measure it, and we can hold them accountable, and we certainly intend to. This is another example of this in Poland. And by the way, China's growing methane emissions accounted for almost 40% of the increase in methane emissions in last year, and the biggest source was from coal mining. You know, just the piles of coal and the mines themselves, even if it's not burned, the methane from coal just sitting there is twice as much as the emissions from international air travel. quite astonishing. And LNG, look, we got to be realistic about LNG. The methane from oil and gas transport made up 60% of the total of oil and gas industry emissions in 2022. And the flaring, and this was part of the commitment yesterday, and that's a good thing, and I congratulate them. But about 15% of the CO2 on average comes from the flaring. Now, this is an example of the intensity of CO2 in different sources of oil and gas. The production here in the UAE, in Saudi Arabia, in Norway, it's less dense with CO2. They say that, and they're correct in saying that. But some of the sources like Russia that are the least responsible are not part of the pledge. So you look at the intensity of these emissions, it varies tremendously from field to field and from country to country. And if you want to reduce your emissions in your supply chain, you can go to the Climate Trace database and make intelligent choices and find emission factors. They may be 56 times higher in some sources compared to the low intensity sources. Now, the industry as a whole is wise to take on this commitment. I hope they follow through. They made their projected profits over the next 7 years are almost $17 trillion. This is the tiny amount of the cost of cutting back on the methane emissions to meet the net zero goals. And some of that can be captured and sold. So the amount that is necessary to spend for the industry is less than 0.2% of their income. I hope they do follow through and meet these pledges. It's important that they do. Now, another data source, road transport. The emissions on highways around the world rose 3.5% last year. And the high income and middle income countries were responsible for more than 2/3 of that. And let's talk about plastics for a minute, because the greenhouse gas emissions from ethylene, which is one of the precursors of plastic, and this is via steam cracking. You know, there's fracking and there's cracking. And this jumped 22% in the last 7 years. And the industry as a whole has three big markets: electricity generation, transportation, and petrochemicals. And if you break it all down, the big growth area is in plastics. And they're projecting huge increases in plastic productions. In fact, petrochemicals are rapidly becoming the largest driver of global oil consumption. And in fact, if you look at petrochemicals, 3/4 of it is for plastics. And they want to massively expand the production of plastics. How's that working out for the rest of us? And they say, oh, well, you can fix it by just recycling. Here is what has been happening, and they're projecting a massive increase continuing at a steeper curve. And I was in West Africa training climate activists 3 weeks ago with the Climate Reality Project, and one of the many places where the plastic pollution is out of control. So you hear that recycling is the answer. It's on us, you know. Well, does that really solve the problem? Here are all the plastics ever made. And this is the amount that has been ever recycled. This is the amount that's incinerated, a bad way to dispose of it. This is all that's in the landfills and in the ocean and on the riverbanks and the highways, and this is the amount still in use. So recycling does not solve this crisis. And at the current trajectory, the emissions from the manufacturing of plastics will outpace the emissions from coal by 2030. This is an outrage, and we have to do something about it. Well, UNEP hosted a global negotiation in Nairobi last month. What happened? The oil and gas companies blocked a treaty. They stood in the path and said no and objected to having a treaty. And you know what they raised as a possible solution? Plastic offsets. They get credit for getting people to go around and pick up plastic elsewhere so that they can count that as a reduction of their plastics. Well, we've heard about offsets before, right? We need some offsets. A small role is proper, 5 to 10%, according to the Science-Based Targets Initiative. But we've seen what happened with offsets with CO2. There's been so much abuse. Chevron, which did not sign the methane pledge, by the way, 93% of their offsets were found to be worthless or junk. So there is a reason why the environmental justice community is opposed to offsets and is opposed to carbon capture and sequestration. Because when they're downwind from the combustion, they get the pollution that makes people sick. My friend Robert Bullard, who may be here, by the way, Professor Robert Bullard from Texas Southern, the father of environmental justice studies here he is right here. Hey, Bob. And he helped us with this data for our presentation. We were up in the wee hours going over this, Bob. Thank you so much. And in Louisiana, we were down in Cancer Alley, as they call it. So the same combustion of fossil fuels that creates the greenhouse gas pollution also creates the particulate pollution that kills about 8.7 million people around the world, largely in marginalized communities, black, brown, and indigenous communities in my country, but likewise marginalized communities elsewhere. Same with carbon capture. The carbon capture doesn't capture the particulate pollution, doesn't capture the methane, doesn't capture the mercury, doesn't stop the people nearby and downwind from getting sick and dying from it when they're in one of these sacrifice zones. So, of course, these are all the carbon capture projects that have been proposed, and these are the small number is what's been implemented. It's been largely a failure, and the International Energy Agency has said it's been a great disappointment. Now they're talking about direct air capture. I'm not going to go into that, but I do want to list one new finding and statistic that for every ton of carbon, CO2 captured from the air, there's 5 to 10 tons of water required for that. And in water-scarce regions, that's just not feasible. Now, we have the solutions at hand here. And I mentioned the intensity of emissions in different industries and different companies in those industries. This is an example with steel, same with oil and aluminum, other materials. You can choose a lower emitting source in your supply chain by using the Climate Trace database. And many companies are now doing this. And the variation in the emissions factor by industry can be almost 200 times larger in the case of rice production, and you can see these other examples. There are companies that are now swapping out suppliers and reducing their Scope 3 and Scope 1 and 2 emissions by making careful choices. So, Gavin, why don't you go through this? These are examples of who is already using this data.
One of the things we were really interested in is it's one thing for a certain facility to have a higher emissions factor than another, but what happens if you just buy from one and the other trails to somebody else? So we wanted to start with a sector where we knew it's actually true if you shift demand from this facility to that facility, it's going to really lower emissions. So what we did is we started in a sector where we know there is a global glut. The global steel industry right now actually has so much capacity that a large number of facilities are running at less than 100% capacity. So what we did next is in the metadata we have from Climate Trace, we actually looked not just at what are the emissions of facilities, but how much are these things getting used? And one of the really interesting things we discovered in the steel sector was the first of several we want to do as a proof of concept. Yes, it is really true that the cleanest facilities in the world often are going largely unused. It is often the case that the cleanest facilities in the world are sitting there idling, largely going unused. It is exactly as ridiculous as building solar panels and then just not turning them on. And we think this is a ridiculous place to be misusing resources when we are in the middle of a climate crisis and talking about investing billions in building new clean facilities. So one of the things we wanted to do is we took the Climate Trace database slightly pre-release. So about a month ago, we went around to many of the largest steel buyers in the world, and we talked to them about, hey, are we just being techno-optimist here? Does this just look like a data project? Or is it really true that you would actually swap out suppliers and you would actually start looking at cleaner facilities? And so we were able, in a very, very short time, to talk to about half a dozen of the world's largest steel buyers. And 4 of them are, in fact, now using Climate Trace data. Again, this has happened very, very quickly, to look at their supply chain and the emissions of their suppliers, look at the emissions intensities of potential new suppliers, and look for opportunities where they could be getting lower emission steel, often at the same price. So we think this is a way to make it possible so that if there are clean facilities out there going unused, those should be the first in line for what companies are looking at sourcing from. And we've been really, really delighted to see how quickly and easily we've been able to get forward-thinking companies to say, yeah, that makes sense. It's sort of a something-for-nothing deal, and we would like to go cleaner. Thank you very much. So after the buyers, we said, what about the smaller companies in the world? Are they all going to do this? And well, what we learned is a lot of smaller steel buyers, they go through data providers. They go through consultants and experts. So the next group of companies we spoke to are those who are in the business of helping companies who buy steel figure out what to buy. And we were very pleased to see that it was almost even easier to get a number of them to say, yes, we would like to start providing these free open data to many of the smaller steel companies out there. Excuse me, steel buyers. And then, of course, because we are very interested in the NGO community as NGOs ourselves, we went around to some of the best known benchmarking and standardization groups in the steel industry. And I want to just emphasize again that this is the result of a very, very short sprint. And the next goal we have is we talk to those same companies about, what about aluminum? What about other sectors that are highly varied in emissions where the cleanest facilities are not getting used? And the short version is that we are expecting a massive scale up this year because this is sort of a something for nothing way to go green in a world where we've gotten used to the idea that usually things take a lot of time and a lot of resources, and this can be a much faster opportunity to reduce emissions. Do you want to?
Oh. So many of you know that the International Energy Agency, thank you, has long since come to the conclusion after careful study that we already have all of the technologies we need with proven deployment models to reduce emissions by half by the end of this decade. There's some people out there who say, well, we don't have everything we need to reduce emissions in half. Well, the IEA is pretty good at this, and others have gone over the same data. We have everything we need to cut it in half by 2030, and we have a clear line of sight to how to get to the other 50% by mid-century. And this is very, very exciting. And in fact, last year, clean energy, renewable energy, made up 86% of all the new electricity generation worldwide that was added last year. 92% in India, by the way, was from solar and wind last year. And we're seeing with electric vehicles, not only the big rise in the sales of electric cars, but also buses and vans, and many more people travel on 2 wheels and 3 wheels than on 4 wheels around the world, and almost 50% of the new motorized 2-wheelers are now electric, and that's very exciting indeed. 2 and 3 wheelers made up 80% of India's vehicle sales, and the electric 2 and 3 wheel vehicles accounted for 92% of the EVs registered in India this past year. Now, naturally, we're seeing a big rise in investments in the energy transition around the world. A new record last year, $1.1 trillion. And investments in battery storage. You know, solar and wind is much more useful as the batteries improve, and they are improving quite dramatically, and you see this incredible surge in investment. You may remember hearing 6-7 years ago about Tesla's Gigafactory. in Nevada making batteries. Very exciting development. You know how many gigafactories there are now in the world? It's a term that is defined by the huge size, the number of megawatts in a battery produced. There are now 195 gigafactories around the world, and another 400 that are in the pipeline being created. It's quite a dramatic story. And the cumulative storage capacity with batteries has increased. I'll have to rescale this graph to show what's in the years just ahead. This is a $1 trillion industry emerging right before our eyes, and it is vastly increasing the efficacy and usefulness of solar electricity and wind electricity. Also, the building efficiency market, very important investment marketplace, and we're seeing a dramatic improvement in the efficiency of buildings. And if you look at the comparison between investments in renewables and investments in fossil fuels, now the investments in clean energy are overtaking the investments in fossil. There's still way too many investments in fossil energy. And by the way, there are still enormous subsidies. But we are seeing legislative action. I'm proud that in my country, President Biden and the Congress have passed the best and largest climate legislation of any country in history. I'm really excited about it. It's likely to result in $1.2 trillion being spent for clean energy and emissions-free energy. And after that happened, around the world, we saw an amazing change of policy in Australia with a new government there, and then a month later, a change in Brazil, and President Lula made a fantastic speech 2 days ago here. I had the privilege of talking with him for some time after that. And the European Union has largely stayed the course in spite of the attempted blackmail by Russia to get support for its sadistic invasion of Ukraine. And yet, we are seeing the temperature continue to increase, and yet we could stop the temperature increases. The new findings from the IPCC are some of the most exciting in all the years that I've been working in the climate, on the climate issue. If we get to true net zero, temperatures will stop going up in the world with a lag time of as little as 3 to 5 years. It's like flipping a switch. Hard switch to flip, because we've got to stop adding to the amount of greenhouse gas pollution in the sky. But once we do that, the temperatures will stop going up. They used to think that there were positive feedback loops that would cause the temperatures to continue to go up even after we reach net zero. No, they're quite certain that's not the case. And here's something else exciting. If we stay at true net zero, approximately half of all the anthropogenic human-caused greenhouse gas pollution will have fallen out of the atmosphere in as little as 25 to 30 years. So we can choose a bright future. We can choose to give young people hope about the future again. We can start the long, slow healing process. If we phase out fossil fuels, that's the answer to it. That's what we need to do. How much do you care about the future? How much do you want to say to your children and grandchildren, we've got you, we've got this? You don't have to have a depressed, sad feeling that everything's just going in the wrong direction. We can change it, you know? But the answer again is phasing out fossil fuels. Half will fall out of the atmosphere. Will have fallen out in as little as a quarter century. Now, here's the problem. One of the many problems that we have to solve is that we have these subsidies. Governments around the world, many of them, are forcing their taxpayers to subsidize the effort to destroy the future of humanity. And these are the direct subsidies, and these are the indirect subsidies. And by the way, the pledge on loss and damage, I think, is a wonderful thing. But as Ajay Banga says, it's only a small start. Here's something to put it in perspective. The amount of the pledges into the loss and damage fund equals 45 minutes worth of annual global government subsidies for fossil fuels. If you include only the explicit subsidies, it gets up to 4 hours worth of the annual subsidies for fossil fuels. So we've got to stop these subsidies. I want to brag on Nigeria, which has just eliminated the subsidies for diesel, and we're seeing an explosion in the use of solar panels there as a result. And we've got to fix climate finance around the world. And many of you know this story. Many of you are working on it. The interest rates for to build a solar farm in Nigeria may be 7 times higher than the interest rates in Europe or North America. In the US and Canada, 96% of the funding for renewable energy is private. Only a tiny bit, 4%, is public. But in Africa, 86% has to come from the government, and they don't have the money. And so we've got to give equal access by taking the extra risk away with the World Bank and the other multilateral banks so that they can have a fair shot at borrowing money like the wealthy countries do to build the solar and the wind and the electric vehicles and regenerative agriculture and batteries and all the rest. And the young people are demanding it, of course they are. And they have a right to believe that we are going to listen and to respond. And by the way, I've often said this, and I'll say it again in closing. If you doubt for one moment that we as human beings have the ability, have the political will to do what's right and to do what's necessary, remember that political will is itself a renewable resource. Go to Climate Trace. The website is open today. You can find all this data for free. And thank you very much for listening to us this morning. Thank you.
Just one more thing. Thank you. We also just wanted to mention one other thing. Which is that the whole point of having all these emissions data, of course, is to beat climate change. So although these data are all free, also, if there's any institution, any government, any company, anyone in the audience who thinks that having better data could help them reduce emissions, we have resources available to actually help you with analysis, help you with technical support, and basically any project that has a reasonable shot of reducing significant emissions with better data will be top of the line, and we are here to serve you. Just wanted to make sure that you walk away with the feeling that you no longer should be thinking that emissions can hide. You no longer should be thinking that there is any source of what you cannot know stopping you from reducing emissions. We are here to help.
ClimateTrace.org.